derivatives of an exponential function, derivatives of a log function. Objectives. By the end of this lesson, you should be able to find the derivative of a general exponential or general log function. Actually, natural log function. Anyway, we know the basic derivative of e dx, right? Derivative of e dx is dx, everybody's favorite derivative. Now it's a little more, and then here it is how on your formula sheet. Now it's a little more complicated. We're gonna do it with the chain rule. What if there's something in the power, right? So the general rule is that there's e to some power. The derivative is just take the derivative of the outside, leave the inside alone, times by the derivative of the inside, right? So the little shortcut is just copy it and times by the derivative of the power. That's it. That's the easy way to do the chain rule with e to the x, because the derivative outside is the same thing. So just copy your derivative and then times by the derivative of the power. So let's see here, e to the 4x, right? So derivative of the outside, leave the inside alone, times by the derivative of the inside, 4. So this becomes 4 e to the 4x. That's it, right? Derivatives of e should still be simple. If there's something in there, it's just this little chain rule. This is one a lot of people get wrong. E to the negative x. So remember the rule. Copy it, then times by derivative of the inside. Derivative of this, the inside is -1. So that becomes negative e to the negative x, right? It's a subtle thing, but a lot of people mess it up. They just put e to the negative x or something. So that's derivatives of e's. It's all stuff we know how to do already. Let's talk about a new thing. How you take the derivative of a natural log. Right? So again, it's gonna be your formula sheet right here. The derivative of natural log is a little weird. It's just 1 over x. So you take the derivative of natural log x, just 1 over x. Now, how does that work with the chain rule? Well, let's say we take the derivative of natural log of u. Right? So the chain rule is take the derivative of the outside. So it's kind of a weird thing. Taking the derivative of the outside is 1 over this and leave the inside alone. So it's kind of all done in one step. It's 1 over the inside. And then don't forget the last part of the chain rule, times by the derivative of the inside. Right? So that's a little weird. Right? So let me do that again. Natural log of, let's say, f of x. Right? Natural log in general is just 1 over the inside. So 1 over the inside. Right? That's, you left the inside alone. Then times by the derivative of the inside. So f prime of x. So that's natural log. So it's a little weird, but that's the general idea. It's kind of a chain rule slash, it's a chain rule, but that first step is kind of put together. So you flip it, leave the inside alone, and then times by the derivative of the inside. So again, a little weird. This is what's in your formula sheet. They don't give the chain rule versions of it. They expect you guys to know those yourselves, but that's what's in the formula sheet. So let's do a few examples. So right, they want me to take the derivative of this. Now again, derivative of natural log is 1 over the inside times by the derivative of the inside. In this case, that'll be 2x. So you get 2x over x squared plus 3. The next one. So this one can actually be done a few ways. The first way is just take it the way it is, right? You take, okay, derivative of natural log is 1 over the inside times derivative of the inside. Now that, either rewrite k to -2, take the power down, subtract 1 off, so it'll be like -2 k to -3, and then you can work on simplifying that. That's one way. Another way is you can just rewrite it. Do that first. It's a little smarter, right? And then you can take the derivative of that the way you know how to do it. It's like, so natural log is 1 over the inside, times derivative of the inside, bring the 2 down, subtract 1 off, and then you could simplify that. That way works too. The most advanced way is don't forget your natural log rules, right? It's a natural log. We're going to talk about this a little more in this video also. So all the same rules in natural logs apply. If you have natural log AB, that's natural log of A plus natural log of B, right? Natural log of A over B is natural log of A minus natural log of B. And natural log of A to the K is you can bring the K to the front. K natural log of A. So I can do that here. Bring that K to the front. I get bring that power to the front, sorry. -2 natural log K. Now look at, that's an easy derivative. Remember, that's a constant, doesn't do anything. It's just -2 times my answer, which is 1 over K. The derivative of K is 1, so that's just that. So I get -2 over K. Right? So you can do it that way. And honestly, I just noticed one other way. If I had this, I could use the natural log rule where I subtract. You're dividing and subtracting. Natural log of 1 minus natural log of K squared. Natural log of 1 is 0. Derivative of that is, well, you bring 2 to the front actually. Good old, and then take derivative 1 over K. Log rules for the win. Right? So it's a lot of ways to do. It's a lot of ways to do the same type of problem. The easiest way is if you know your log rules, right? Divide means subtract. And again, we're gonna do a little bit more of this later. And if you have a power, you can move it to the front. So look at this next one. This is an e problem. F of x of e to the 2x over 2x. And then find the derivative. Now there's no shortcut to this one. All it is, it's a quotient rule, right? So uv, remember the quotient rule is the derivative of the top times the bottom minus flip it, derivative of the bottom times the top, all over the bottom squared. Right, so if I was going to do this, derivative of the top, so remember, the way you take the derivative of e to the 2x is copy it times by derivative of the power, right? That's a chain rule, so it's a little chain rule right there. So, right, my u is e to the 2x, my u prime is copy it times derivative of the power. I take derivative of the outside, leave the inside alone, times by derivative of the inside. So that's my u, times it by v, so 2x, minus the other way around, derivative of the bottom is 2, and then leave the top alone. All over the bottom squared. Now keep in mind, bottom squared is parentheses 2x. Don't just give me 2x squared, it's parentheses 2x. Now if you want to simplify that a little bit, you could. You get 4x e to the 2x minus 2e to the 2x all over 4x squared. Again, it's only if they ask, you have to do that. Otherwise, that's fine. And if they ask, they're probably going to want you to factor out the e to the 2x on both. So honestly, if this was to make it look like this, it'll probably be like this. E to the 2x you gotta factor out, 4x minus 2 all over 4x squared. That's what you probably have to make it look like. But anyway, that's the problem, right? So not that bad if you're pretty good at your quotient rule, you're pretty good at your chain rule right there. Next one. So find derivative of f of x equals natural log of this. Now look at this mess. But it's natural log, so we know what natural log is. It's 1 over the inside left alone. That's my little chain rule here. Times by derivative of the inside. Now derivative of 1, x is 1, derivative of 4 is 0. E, remember, that's its own little chain rule. You copy it, and it times by derivative of the power. So that's going to be e to the negative 3x times negative 3. So I get this monstrosity. And I forgot an x right here. Sorry about that. So we have that, and then notice they want f prime of 0. So we want, again, that one's plug-in 0. Sometimes people start setting stuff equal to 0. That's plug-in 0. If I said this, then you set equal to 0, right? So it's a very big difference. That gets plugged in. So you plug in 0 here. You basically get, I'm showing a lot more work than I expect you to. E to the 0 over 0, there goes there too, plus 4 plus e to the 0. Anything to the 0 power is 1, except for 0. So you just get 1 minus 3 over 4 plus 1. Almost forgot the 1 right there. So 1 out of 0. And you get negative 2 over 5. Right, so again, just take a derivative. Natural log is this 1 over the inside times the derivative of the inside, right? The chain rule part. Don't forget about the derivative of the inside. And that's itself, it's a little chain rule. It's a chain rule inside a chain rule, right? But these should be easy. Just copy them and then times by derivative of the power. So let's look at this one. Now, we don't always have to jump the gun with our e, or let's look at some e rules basically. So we're looking at this one. Look at this. If you start going, okay, derivative of natural log is 1 over blah blah blah. Hold up. Natural log and e cancel each other out. This is just a derivative of 2x. So it's 2, right? Don't forget your natural and your e rules, right? Natural log of e equals 1. E to natural log, same idea, just equals x. That's what we're going to use actually very soon right now. Right, so don't forget all those basic rules. And like I mentioned, let's try to use this one right here. F of x equals e to the 3 natural log x squared. That looks disgusting, right? Like it's all, I'm going to copy it and times the derivative of that, and that's its own mess. But don't forget, if you have e and natural log next to each other, they cancel out. Now that doesn't count because there's 3 in the way. Right now I have this. So I can't cancel them out because that 3 is in the way. Pesky 3. But don't forget my favorite rule of logs. If you have natural log a to the k, you can bring the power to the front or vice versa. Let's bring this 3 up here. So you get e to natural log x, remember powers multiply like that to the 6. These cancel, and you just get f of x equals x to the 6. Take the derivative, bring 6 down, subtract 1 off. 6x to the 5th. That's the derivative. Right, so it's so much easier if you know your log rules. Right, so all the basic ones, the natural log cancel out, adding, subtracting, adding, multiplying, subtracting, dividing, yada yada. Let's do a couple more. This first one here. Right now, there's no shortcut out of this one. You just take the neat one. But remember, e shouldn't be that bad. You just copy it. Then times by derivative of the inside. Derivative of 1, 0. Derivative of that is negative 4x. So if we want to make it a little prettier, you can do this. Again, unless they ask you, you don't need to. Now you look at this one. Right? Hold up for a second. You're multiplying two things. This is a product rule. Right? You're multiplying, product rule. I don't want to do that up here. I don't know. I don't have anything up there. Remember, that's very different because it's an x and an e to the x. If I had something like this, not a product rule because that's a constant. I don't have to worry about it. Product rule. So, right? Product rule is derivative of the first one, so 3x squared times the second left alone plus derivative of the second one. Now, remember, that right there, that's a little chain rule. Right? E's are always a chain rule, so copy it times by derivative of the inside times the second one left alone. So that's your answer. Again, let's say you want it prettier. If they do, then you could do, let's simplify a little bit. That's going to be negative x cubed e to the negative x. Again, only if they ask. Even though you could still factor out the e to the negative x if you wanted to. Probably factor out some more anyway. I'm going to stop going because I'll just go down rabbit hole of factoring. So let's look at this one. Now, again, we could do this 1 over the inside times the derivative of the inside, which is pretty much it's another product rule like we did earlier. Or we use limit laws. Right? They're multiplying. That's addition. So you have natural log of x plus natural log of e to the negative x. And it gets even better. Natural log of e cancel out. This is just natural log of x minus x. Now before you go, you're like, okay, done. Don't forget, we just did algebra. The question was the derivative. Well, it's up there. You still have to take the derivative of this, so don't get all excited with your algebra. You still take the derivative. So natural log of x is just 1 over x. Right? That's what it is. And natural log minus x is just minus 1. Right? So much easier if you know how to if you know your limit laws. And with that in mind, let's go to one of our final ones. Right here, right? That looks like a mess. Right? 1 over the inside, that's all that messy times the derivative inside. It's a product, it's a quotient rule inside of that. It's gonna be a mess. Or limit laws. Natural log laws. Right? Remember, top is addition, so natural log of x. Anything being divided is subtraction. Minus natural log of x plus 2 minus natural log of x plus 2. X minus 3, sorry. Right? Look how much easier of a problem that is. It's because we know our natural log laws. Right? So now, this, remember, natural log is this 1 over the inside times the derivative of the inside. Sending over here, 1 over the inside times the derivative of the inside, in this case 1. And sending over here, 1 over the inside times the derivative of the inside, 1. These reduce right here. And you just get 1 over x minus 1 over x plus 2 minus 1 over x minus 3. Look how easy that is, just because we know our natural log laws. Okay, last couple. Just notice I've been saying limit laws, I meant log laws, but you know, whatever. Okay, so let's look at this one. Find the gradient of the tangent line to the tangent y equals x natural log x to the point where x equals e. So first of all, remember gradient means slope. It's a fancy way for saying slope. And it says slope of the tangent line. Remember, that's just code for derivative. That's all that is. We need to find y prime. So now we're going to take the derivative of this. Look at that. It's a product rule, right? You're multiplying x times natural log of x, so it's a product rule. So don't forget that. Don't just give me 1 times 1 over x or whatever. It's a product rule. So derivative of the first one, derivative of x is 1 times the second left alone plus derivative of the second. Remember, derivative of natural log is 1 over x times the first left alone. For your own benefit, since we're plugging e, you want to simplify this. Natural log of x plus 1. Now all you got to do is plug in e. Right, well, plug E in. Natural log of E plus 1. Natural log of E cancel, you just get 1 plus 1 is 2. Right? Nothing to it. Last one. The amount of coffee in a cup in ounces is modeled by B of t 16 minus 16 e to the negative 0.4 t. Use this model to find the rate of which the coffee is changing when t equals 5. Right? So we want to find the rate at which the coffee is changing at t equals 5. But you know what they're asking for? We only want to know how fast it's changing at 5. That's the instantaneous rate of change. If that word sounds familiar, it's because it is. It's the derivative. Right? So anytime I want to figure out how something's moving or changing at a certain time, it's called the instantaneous rate of change. That's just a derivative. So we're going to take a derivative of this and then plug in 5. Now, so 16 minus 16 e to the negative 0.4 t. Let's take a derivative. Right? The derivative of 16 is 0, goes away, so it's a constant. Remember the way you do the e, just copy it, right? Constant, that's just constant too, so copy it. Times the derivative of the power, in this case would be negative 4, negative 0.4. And after we do that, we just plug in 5. So my answer is going to be negative 16 e to negative 0.4 times 5 times negative 0.4. And if you want to simplify, you actually can. Negative 16 e negative 0.4 times 5 is 20 or 2.0. So negative 2 times negative 0.4. That's 4 over 10 times 16, and this is fine. Okay, we're done.